up to 5 coaches. Now, what you see on the board has connection 1, M1, M2, and M3. And also, there's an applied force, which is FA. Now, a trade also has a place where the NG puts all the coaches. Now, first thing first, before we could go in demystifying this problem on the board, we'll make few assumptions. Now, the first assumption is that the floor is frictionless because of the tire. So we'll assume that the floor is frictionless. Even without the tire, we'll also be told that the floor is frictionless. That is, the friction between the object or the diagram and the floor is negligible. So we'll assume that the friction is negligible. Another assumption that we are going to make here is that the connection between mass M1 and M2 has tension in between. So there's tension here, T1, and the mass M2 and M3 also has a connection, T3, which is the tension is present between M2 and M3. So we'll call this one T2. So in solving this problem, we are going to take the different coaches, the different masses, and solve them individually. Now, we'll consider mass M1. Considering M1 has a tension, just a tension, because the friction in M1 and M2 and M3 is negligible. So it has just the tension moving forward. So T1, this is N1. So to apply our Newton second law, which states that the net force is equal to the mass times acceleration. So Newton second law gives us mass times acceleration. So the net force is the tension. So T is equal to M1A. So this becomes our equation 1. Now let's go to mass. Let's consider mass M2. Now if you consider mass M2, we have M2, which is T2 and T1, T2 and T1. So if we look at it, we also have our Newton's second law applied to the second mass. If we apply the Newton's second law, we have the net force. The net force, which is T2 minus T1 equal to M2A. So for that, make T2 the subject of the formula. T2 is equal to M2A plus T1. Now replace what T1 stands for in equation 1. We are going to get T2 is equal to M2A plus M1A. So we've been able to demystify the forces acting on M2. So we are going to look at the one acting on M3. So we'll consider the mass M3, which is the applied force, and the tension T2. So we'll also apply the Newton's second law to the mass M3. Newton's second law, which is F net, is equal to MA. That is, our net force is the difference between the two forces acting on M2. So that is F applied force minus tension 2 is equal to M3A. So we'll make FA, which is the applied force, the subject under FA is equal to M3A plus F plus T2. M3A. And we know that our T2 is equation 2, which we just obtained. So equation 2 is M2A plus M1A. You can see from this last equation that the acceleration is the same. So Fa, we factorize it in bracket M3A, M3 plus M2 plus M1A. Now, this is a formula to obtaining the applied force. Now, I want you to interpret this formula. This formula indicates that in real life situation, when a train is moving, it comes with the full force, that is the force acting on mass M1, M2, and M3. So it is very dangerous, it is very annihilating to place an object in front of a rail track. The destruction is always massive.